In this video, we're going to be looking at some harder examples of solving equations. And these are a little more difficult than what I've done in my previous video, just because here we're going to be working with decimals and with fractions. So even though it's still really the same steps, the same concepts, they're just going to be a little more difficult. All right, so here's my first example where we're solving an equation, and this one, of course, has some decimals in here, but we're still really using the same two rules as before. So the first rule is opposites cancel each other out, so I can remove things by doing the opposite. And the second rule is we need to keep that equation balanced. So what I do to one side, I have to do that to the other as well. So this first example here, there's a lot of different ways to start this off. You could start by subtracting this 3.1 to get rid of it. You could subtract this 0.6x to get rid of that. Or here I could do the opposite of this, which would just be plus 3.12. But it doesn't matter how you start this problem off, either of those ways, we should still get the same answer at the end. Okay, so these opposites are going to cancel. I can remove those. Over here, I'm just going to bring down what I don't change. So the 1.4x, bring that down. These, I'm going to add these together. This would give me 6.22. And I'll just bring this down to 0.6x. And of course, the last part canceled out. So on the next step, again, there's kind of two ways I could go about this. I could subtract the 1.4x over here. I could subtract the 0.6x over here. But it looks like it's going to be easier to do it this way, 1.4x. I'm just subtracting that from both sides. And of course, that's going to cancel these, which is what we want. So what's left is the 6.22. And that's going to equal, here I have to subtract these. When I subtract, I get 0.8x. All right, and our last step, so again, opposites cancel each other out. So our last step, this 0.8 is multiplying the x. I would need to divide both sides by 0.8. Actually, this is a negative, right? Negative 0.8. And we'll divide this side too. Rule number 2, got to keep the equation balanced. So when I divide these, what I'm going to end up with is this cancels out. All right. And when I divide these two decimals, we end up with negative 7.78. All right. So kind of a weird answer here just because this problem has decimals in it. Let's look at another one. So this one, same thing, solve the equation. But again, it's going to be a little trickier just because of all these fractions. And the first thing that I notice is this one's negative, this one I'm adding. But to add or subtract fractions, they all need to have the same number in the denominator. So this is a 6, a 3, a 2. We want them all to be the same. The easiest way to do that would be to multiply this fraction by 2 over 2. And that'll give us a 6 on the bottom. The other fraction over here, I can multiply this by 3 over 3. And again, that'll give us a 6 in the bottom. All right, so let's first bring this down. I did not change this, so just bring that down. And the red fraction, we're just going to multiply this, would be 2 times 2 is 4. 2 times 3 is 6. And for the blue fraction, we'll also multiply 9 times 3 is 27. On the bottom, 2 times 3 is 6. So now these all have common denominators. Now I can actually work with these, subtract them, add them, and whatnot. So let's first get rid of this plus 4, 6 by subtracting 4 over 6, so I'm just doing the opposite to cancel it. And these will cancel. So what that leaves me with is just negative 5 over 6x on this side. And then the blue fraction, I can actually subtract these. So 27 minus 4 is 23. And then the bottom just stays the same. These are common denominators. What about our last step here? So this is a little tricky. To get rid of this negative 5 over 6, I just want to do the opposite of that. So I'm actually going to multiply by the opposite, a negative 6 over 5. And same thing over here, I'm going to multiply this by a negative 6 over 5. It's sort of like keep, change, flip, kind of the same thing there. These are going to cancel because they're opposites. Look at what we're left with. X equals, let me rewrite this, 23 over 6, and then the purple one, let me just rewrite that. It's going to be negative 6 over 5. And again, what we really did was just keep, change, flip. So these, I can multiply these out. I could do 23 times negative 6. I could do 6 times 5, and then I would reduce that. But just notice you have a 6 on the top and on the bottom. These are really just going to cancel. So take that shortcut, cancel those out, and look what you're left with. 23 over 5. That would be our answer for this one. So again, if you don't notice that shortcut that you can cancel these, you could also multiply them out, reduce, simplify. You would still get 23 over 5. Okay, my last example, this one, it says solve the equation for r. Here this is s equals 4 times pi times r squared. So even though I'm not going to get like a number when I solve this, I'm just going to get a different equation. What I'm trying to do is still get the r by itself. I want r equals the rest of the equation. So I'm still following those same two rules. To cancel out the 4 and the pi, these are both multiplying the r squared. I just do the opposite. I'm going to divide these out. All right, that's going to cancel these. Look what's left. Over here, this is going to be s over 4 pi, which does not reduce. It doesn't simplify anymore. We just leave it like that. And then over here, this is r squared. What's next? To get rid of this square, this 2 exponent, I would just do the opposite of square, which is square root to both sides. All right. So over here, I'm just going to get radical s over 4 pi, which is not going to really simplify any more than that. We're just going to leave that alone. Over here, these cancel. The radical and the square, those cancel out, which is what we want. This is going to be our answer, even though it looks kind of weird. Here we've solved the equation for r. All right, so just a few more examples on solving equations. Hopefully that helps you out, guys.